We tend to assume that making a product smart is always an upgrade, but that assumption overlooks a critical tension. The smarter a tool gets, the more likely we are to make simple and sometimes even dangerous mistakes with it. So why does this happen? It all comes down to a fundamental conflict between how these automated systems are designed and how our own minds are wired to interact with them. Much of the frustration we feel with new technology is a direct result of this mismatch. To understand this, the first place we have to look isn't at the technology. It's inside our own heads. We have a deep-seated, often unconscious tendency to put too much trust in automated systems.
Take a high-stakes environment, like an airplane cockpit. In multiple studies, experienced pilots have received false alerts from their flight computers. And what happened? A significant number followed the computer's bad advice, even when it meant shutting down an engine that was working perfectly fine. This isn't a fluke, it's a well-documented cognitive pattern.
This pattern has a name: automation bias. It's our natural tendency to favor suggestions from an automated system and to ignore contradictory information even when our own senses or training tell us something is wrong. We are simply predisposed to let the machine take the lead. So why do we do this? It happens for a few key reasons. First, there's the cognitive miser hypothesis, which says our brains are wired to save energy by taking the easiest mental path. Second, we often perceive automated systems as having superior analytical skills. And finally, when we share a task with a machine, we tend to reduce our own mental effort. Together, these create a powerful incentive to let the machine do the thinking. And this can lead to two very different kinds of errors. The first type is an error of commission. This is when you do something wrong because the system told you to, like a driver following incorrect GPS directions into a dangerous area. You take an action based on bad advice. The opposite is an error of omission. This is when you fail to act because the system didn't alert you, like a pilot who stops monitoring instruments, assuming the autopilot will catch any problems. So our own cognitive biases set the first trap. But there is a second one, and this one is built right into the design of the technology itself. It's all about the hidden cost of constantly adding more features, more options, and more complexity. This gets at a core design principle known as the flexibility usability trade-off. The idea is simple. As a system becomes more flexible and can do more things, its usability for any single specific task tends to go down. Here's a perfect example of that trade-off in action. One user reported spending 11 hours just trying to make 1 cup of tea with his new Wi-Fi-enabled smart kettle. The added smart feature introduced so much complexity that it made a simple function nearly impossible. What's happening here is information overload. When a product is packed with features, settings, and data streams, it can completely overwhelm our ability to make a simple decision. A device that's designed to do everything can become incredibly difficult to use for any one thing. And this isn't just about one person's kettle. This frustration is reflected in the data. Research from PwC found that 64% of U.S. consumers feel that companies have lost touch with the human element of customer experience. This suggests that in the push for more smart features, the user's actual needs are sometimes getting left behind. This all raises a really important question about design philosophy. If adding more complex, attention-demanding features is creating these problems, what's a better approach? Well, the alternative involves a fundamental shift in thinking. What if the goal of technology wasn't to constantly demand our focus? What if instead its job was simply to inform us, quietly, in the background? This philosophy is called calm technology. Its core idea is that the interaction with a device should happen in our periphery, not front and center. It provides information without being intrusive, and it only moves to the center of our attention when it's absolutely necessary. This approach has 3 guiding principles. Technology should require the smallest amount of our attention possible. It should use our periphery to inform, not demand focus. And it should create a subtle sense of awareness. An early example from Xerox PARC was a simple string connected to a network cable. As network traffic increased, the string would just whirl faster, giving people a peripheral sense of activity without a single distracting notification. Understanding these forces, both our cognitive biases and these fundamental design trade-offs, is really crucial for how we think about the technology in our lives. The objective here isn't just to avoid frustrating products. It's about designing tools that truly serve human needs without overwhelming our cognitive resources. The most effective technology doesn't try to replace human thinking, but rather augments it, all without adding unnecessary mental load. And this brings us to a final, crucial question. How do we shift the focus from creating technology that mimics people to building technology that actually empowers them? The answer may lie in designing for our periphery instead of our focus, creating tools that are less artificially smart and more genuinely and quietly helpful.